The screen recorder so rudely interrupted me, so let's recap what I just did. I took the natural log, I factor out the 2, so it's 2 times x minus 2, and if you recall our log properties, we can break up ln of a times b as ln of a plus ln b. So I'm going to rewrite this as the natural log of 2 plus the natural log of x minus 2, and you might see, well, there we go. Found another piece that matches. So then you might be thinking, well, what about that minus 1 and this plus ln of 2? Well, take a look at the 3 things I just highlighted. Negative 1, it's a constant. Natural log of 2, it's a constant. C is some constant. Something that us mathematicians tend to do is when we look at all 3 of these things and we say if we're adding them all together, what are we going to get? We're just going to get another constant. So maybe you call it C1 to distinguish it from C, but it's still just a constant. So instead of writing minus 1 plus ln2 plus C, we might just write C. So this C right here, in that second answer that we get, kind of encapsulates, has within it, even though we don't see it, that minus 1 plus ln2. So even though we don't have all the pieces that match, these 2 highlighted answers are identical to each other. They don't look it, but they are. I'm trying to erase some circled stuff to make it a little less busy, but I don't want to erase all the stuff that I wrote. There we go. All right, to wrap things up, solving a differential equation. To solve a differential equation is to find the function. In this case, since we're doing dy dx, we're going to find what our function y is. So we'll be spending some more time with differential equations in chapter 6 in a couple weeks. But for right now, basically what it's asking you to do is if we're going to find y, then we need to integrate the derivative to go back up our level. I'm going to move the dx to the other side. Call this thing kind of like a separation of variables. We'll go over that more in the future. Kind of moving the dx to the other side so that it kind of looks a little bit more natural to integrate both sides here. What is the integral of dy? That is y. We won't worry about the plus c because we'll do that on the other side. And then we're just integrating 2x over x squared minus 9 dx. This looks like a u sub thing to me. If I call my u x squared minus 9, then my du is 2x dx. Oh, how nice is that? That's that right there. So our integral becomes 1 over u du. So our answer is the natural log of the absolute value of u plus c, which of course we're going to go back in and write natural log of the absolute value of x squared minus 9 plus c. Now for our last problem, it looks a little bit more tricky, maybe is a little bit more tricky, but it's going to be the same idea. I'm going to move that dx differential to the other side. And if we're solving the differential equation, because we're doing some very low-level differential equations, all we have to do is integrate both sides. So we're going to get y equals. Now how do we work with that integral on the other side? Picking your u a little bit more challenging, but if you can kind of think ahead and think about derivatives, you might notice that if we choose our u to be the natural log of x, we take our derivative, we get du equals 1 over x dx. This is actually pretty good, because this x right here is in a denominator. This x right here is in a denominator. These things match. The things that I highlighted can be replaced for du. So it actually works to our favor that x is in the denominator. We haven't had a whole ton of problems that have looked like that. But in this case, that x being down in the denominator actually allows us to do our substituting. So we can rewrite our integral. I'll move the 3 out to the front, make it easy on my myself. So we have a 1 on top. The x dx is the x in the denominator. Dx is getting replaced by du, and the ln of x we're calling u. Integral of that, not too bad now. We get 3 times the natural log of u plus c. And then we just got to rewrite what our u stood for, and this is where it looks a little funky. Inside of our natural log, we have the natural log of x. So it is 3 times the natural log of x plus c. Don't forget your absolute values. Looks a little weird, but there we go. Hopefully this stuff has made a little bit of sense. Try your homework best you can. When I'm back, we can go over some things if stuff didn't make sense. Otherwise, on Monday, we will be talking about integrating our 6 trig functions.